All right, so we've been asked to find the antiderivative of the following functions, and we've been asked to check those antiderivatives by taking the derivative. So let's start with the antiderivative. Now, with the general power rule, with a derivative, the power goes down by 1. With the general power rule with an antiderivative, the power goes up by 1. So the first thing I'm going to write, the antiderivative of x to the 6th, is going to be x to the 7th. That's the first thing I'm going to write. Now, when I go to take the derivative of this, it's going to be 7x to the 6th. Well, there's no 7 here. So I'm going to have to put something that makes sure that cancels out, and there it is, 1/7. Okay? And then, of course, the last thing for every antiderivative ever is to add plus c. Okay, I'm going to put a box around that. There is my antiderivative. Now, to make sure that I'm correct, I'm going to come over here and take the derivative of 1/7 x to the 7th plus c. Okay, well, the derivative of this, I'm going to multiply by 7, so that gives me a coefficient of 1, x to the 6th, and the derivative of a constant is 0. Okay, matches, so I know my answer is correct. Cool. All right, next, the antiderivative of 2. Okay, now I want you to picture this as the antiderivative of 2x to the 0. Okay, because that's what it is. It is x to the 0. Okay, it's x to the 0 power, because remember, x to the 0 power is 1, and 2 times 1 is just 2. So, haven't changed the problem at all. I've just changed the way it looks. So here, I had a 6. I changed it to a 7, right? Plus 1. The power goes up by 1 when we're taking the antiderivative. So here, this is 0. The first thing I'm going to write is x to the 1. Okay? Now, when I take that derivative, it's going to be 1 times whatever the constant is. So I can go ahead and put a 2 there, because 1 times 2 would be 2. So I'm always taking the derivative in my head, if that makes any sense. Okay? And then plus c. And that is going to be my antiderivative. Okay? That's going to be my antiderivative. And if I were to check this, so just come along here and say, okay, what is the derivative of this function? And the answer would be, well, 1 times 2 is 2, so it'd be 2. And then subtract 1 from that would be x to the 0, which would just be 2. Okay, so I did check that. It does work. That is the correct answer. Okay, so always check these with the derivative. All right, next one here. I've got the antiderivative of x squared minus x plus 2. And immediately, I'm going to break this into the antiderivative of x squared dx minus the antiderivative of x dx plus the antiderivative of 2 dx. Okay? And my intention here, obviously, is to use the sum and difference rule. Right? Sum and difference rule says I can break these into 3 separate little problems. Well, the antiderivative of 2 is 2x plus 1, 2x to the first plus c. So I'm going to go ahead and just write that's 2x to the first power plus c. Okay? And then the derivative of x, well, that's x to the first. So I know that's going to be what? X squared. Okay, so that'll be x squared. And the problem is, if I take the derivative of that, it's going to be 2x. So I've got to put something to counteract that. So that'll be negative 1/2 plus c. And since this guy has a plus c and this guy has a plus c, I'm not going to write it again. So minus 1/2 x squared. Okay. And this guy, immediately I'm going to write x cubed. And then if I take that derivative, it would be 3x squared. Well, there's no 3 here, so I've got to counteract that. So I'm going to counteract that with the 1/3. So that'll be 1/3 x cubed, right? So there's my antiderivative. And then if I were to check it, right? So if I were to come in here and check it, if I were to say, all right, dx 1/3 x cubed minus 1/2 x squared, 1/2 x squared plus 2x plus c. Okay, what's the derivative here? Well, 3 times 1/3 is 1. 2 times 1/2 is 1. And then derivative of 2x is just 2, and the derivative of a constant is 0. And so I get what I started with. So I know that's correct. So I can always check these using derivatives. And so if you're good at derivatives, you know your antiderivative is correct before you move on. So antiderivative 1 over x to the 5th. All right. First thing I'm going to do is rewrite this as the antiderivative of x to the negative 5th dx. Now, this is where people kind of boo-boo, but you've always got to remember, if this is a 2, antiderivative is going to be a 3. It's going to be plus 1. So his antiderivative is going to be x to the negative 4th. Okay, plus 1. Okay, the most common mistake I get for these types of problems is someone will put minus 6 because they're trying to make it quote unquote bigger. Okay, but remember, bigger means more positive. Okay, so add 1, so x to the negative 4th. Now, if I take his derivative, it's going to give me negative 4x to the negative 5th. So this has to be negative 1/4. Okay, so negative 4 times negative 1/4 is positive 1x to the negative 5th. If I take that derivative in my head, and then plus c. And then, of course, the last thing is you don't really want that negative exponent in your answer. So you're going to take this guy and rewrite it as negative 1 over 4x to the 4th plus c. Okay? That would be our antiderivative. And you could check it with the derivative, right? If I go back to this form, we've already done that kind of mentally, right? Negative 4 times negative 1/4 is positive 1. Subtract 1 would be x to the negative 5th, and then its derivative is 0. So mentally, you can kind of check it. You don't have to show it every time. You can do that mentally, okay? So there's finding antiderivatives and checking with derivatives, okay? So if you have any questions, let me know. Simple antiderivatives. We'll do a couple more videos where they get a little more complicated.